Flack math! Give me some math and I'll give you some flack. Flack math!
We're going to talk about diagonals of polygons. Okay?
That sounds interesting.
They are. Very interesting.
Sounds interesting.
Okay, so a diagonal of a polygon. So connects two non-consecutive vertices. What does it mean to be consecutive? Yeah, so what if I had two consecutive wins, our baseball team, what does that mean? 2 games in a row. That's right. So you have 2 wins or you have 2 consecutive wins. There's a difference there. I mean, it's still just 2 wins, but 2 consecutive means there's one after the other. So if you have like a polygon here, A, B, C, D, a diagonal would connect 2 non-consecutive vertices. If they're consecutive, it would be like C and B. What happens when you connect C and B?
You get a line.
It's just one of the sides, right? So do you see why it has to be non-consecutive? So here's a diagonal. This is a diagonal. It's almost looks like another word in another type of shape.
Diameter.
Diameter, that's right. So that's a good way to remember it. Sometimes like the diagonal doesn't have to necessarily go through the middle, but sometimes it could. Like in a square, a diagonal goes through the middle. In a rectangle, it kind of goes through the middle as well. All right, so that's a diagonal. So AC would be considered a diagonal of quadrilateral ABCD. Okay, so that's the technical language behind it. How many diagonals do you think we could draw in this quadrilateral?
3, 2, 3, 9.
Okay, so where else can I draw one? If I go to B, I could probably draw one there, right?
Yeah.
What if I go to A? Oh, that's the same one. What if I go to D? Oh, that's the same one there. So there's only 2 diagonals we can draw. All right, what about this? How many diagonals do you think we can draw in this hexagon? So 6 vertices. How many do you think we can draw? Grace?
3. That's what I thought.
Okay, let's try it. So let's just go from like one of these points. So if I go from here, I can't do that one, right? So I'm going to go there.
Oh.
I'm going to go there. So there are 3 from one vertex, but I can also go from here.
3 from every.
So here's one, here's one, here's one. And then from here, I'm repeating myself one time, but here's a new one. Here's a new one. If I go from here, I'm repeating myself twice, but I still can do this one. And then once you get over here, that's all the diagonals you can draw. So that looks pretty cool. Okay. What am I know, it looks like some evil symbol there. Okay. So you got like 3 from each vertex, but some of those repeat themselves. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know.
That's
But-
right.
It looks 3D.
I think it's 7.
But if you just do it from one vertex, so let's just do it from one vertex, even though that looks cool. From one vertex, it kind of makes sense that you can only draw 3, because you can't, if there's 6 total vertices, 6 corners, it makes sense that you can't draw one to itself, right? And you can't draw one to the 2 consecutive ones, right? So it's basically the number of vertices minus 3. So on a nonagon, which is 9 vertices, how many diagonals do you think you can draw from one vertex? 6. 9 minus 3. So subtract the one you're on, and then subtract the 2 consecutive ones. So it's always minus 3. So how many diagonals can you draw on a triangle?
0.
0. Think about it. Think about a triangle and try to draw a diagonal. Well, you can't because all the sides are connected, right? So you can't draw a diagonal in a triangle. So a triangle
So you
has
can
no
draw-
diagonals. Yes.
All the sides are technically connected in a circle, but you still can draw many diagonals. In the circle, there's
In a
no-
circle, yeah, but not in a triangle. So a triangle, a diagonal has to connect 2 non-consecutive vertices, okay? So basically this creates 4 triangles. You see the 4 triangles?
Yeah.
Okay, here's triangle 1, 2, 3, 4. Now, let's think about something for a second. What do all the angles in a triangle have to add up to, the measurements?
180.
180. So if there are 4 triangles in here, so the total measurement of all the angles is going to be 180 times 4, which is 720 degrees. Okay, so there's 3 diagonals, there's 4 triangles. So all the measurements, the angles, the measurement of the angles in a hexagon add to basically 4 times 180, which is 720 degrees. Okay, now there is a nice little formula. All right, the number of triangles you can draw in a shape is however many sides it is, or vertices, same thing, minus 2. So how many triangles can you draw in a triangle?
1.
3 minus 2 is 1. How many triangles can you draw in a quadrilateral?
4.
4, or just 2. Because 4 minus 2 is 2. Look, there's one there. If I'm just talking from one,
Oh,
so don't forget about that. So there's just 2 there and there. All right. How many triangles can you draw inside of a decagon?
the deck is 10.
10 sides, yeah.
Oh. What?
How many triangles? 8. Just subtract 2. So it's basically n being the number of sides or number of vertices, same thing, minus 2 all times 180. So that's how you can figure out how much, what the angles all have to add up to. So if I measured this angle, this angle, this angle, this angle, this angle, and this angle, that would all add up to 720 degrees. No matter how it's drawn, I could have drawn the hexagon like this. Okay, all those angles, inside angles, interior angles, have to add up to 720 degrees. Okay? All right. So exterior angles is different. Exterior angles are the angles on the outside. Now, but it's not what you think. It's not this angle here. It's this angle. So if I were to extend this line here and extend this line here, this is going to look really cool. This looks like something that was wet, that was spinning around and all the water sprays. Okay, so these are called exterior angles. Exterior angle. Exterior angle. Exterior angle. So if you just extend the side, the angle that's formed when you extend one side is called an exterior angle. Okay, so it's not like from here to here. It's just when you extend the side, that's the exterior angle. Now, imagine walking around this building. How many degrees do you think total? What do you think the external angles add up to? Do you know?
720.
Nope.
Oh,
Do you know?
360.
Yeah, because look,
Oh.
start here and you turn a little bit, turn a little bit more. Eventually, you're going to end up right where you started. So how far did I turn around? A full circle, which is 360 degrees.
I have a question.
Yes.
Why are you walking around that very small building?
I don't know, because I'm bored. I need to get my steps in. I don't do steps, but I should.
Watch on it and stuff.
Well, you can do it. Your iPhone technically doesn't do a good job, but it typically tracks it. All right, I'll get a watch, okay? Jeez.
You could use Pokemon Go.
What?
You could use Pokemon Go.
Does that track your steps? I don't know if I could. Pokemon Go. Remember
Mr.
that?
Flack, the intense Pokemon goer.
Remember that craze? That like changed the world.
Then some guy like fall off a cliff.
Yeah.
And I heard someone got hit by a car.
What? It literally says at the beginning of the game, watch out for your surroundings. They're just like, yeah, whatever.
Yeah. Okay, so no matter what shape it is, this will always add up. So on a decagon, on a million-gon, okay, it will always add up to 360 degrees. Think about it. You're always going to end up going around and ending up right where you started, facing the same direction. So that's 360. I just got dizzy. Okay, so the sum of exterior angles is always 360 degrees, no matter what shape it is. Triangle, quadrilateral, pentagon, hexagon, anything. It always adds up to 360 degrees. How's that feel? Does that feel all right? So a little bit of a geometry lesson there, but just on diagonals and then interior and exterior angles. So without looking here, how do you figure out the sum of exterior angles in a dodecagon?
You just know it's 360.
Yeah, so you're like, who cares? Because it doesn't matter how many sides it is, it's always 360. Okay, how do you find, so raise your hand, don't say it out loud, but tell me how to find the sum of interior angles in a dodecagon. Do you know, Grace? Were you raising your hand or
Yes,
itching your
I'll
head?
raise my hand.
Or both?
Both, kind of.
Okay.
So you get the number on the sides,
Okay, so that's 12.
subtract it by 2,
Okay, 10.
and then multiply it by 180.
Yep, so you can do that in your head. What's 10 times 180?
One.
Just add another 0.
Yep. So 1,800.
All right, 1800 degrees. The sum of all the interior angles in a dodecagon is 1800 degrees. Okay, good?
Yes.
All right, moving on to lesson 90. 90. So, after today, 10 more lessons, we're done. Okay, so that's basically 4 lessons a week, right? So that's like 2.5 weeks and we're done teaching. Not you, I am. You're done learning.
I have a question.
Yeah.
What happens after if you like finish all the lessons before the school year ended? Then what do we do for the rest of those days, time day?
Then we
Like a ton of free days.
no, we're going to finish before the school ends, but we're gonna spend 2 days reviewing for our last test just to make sure you got it and you feel good about it. And then you're gonna take the test on that Thursday, which is not the last day of school, but it's the second to last day of school. And if you don't finish it in class, you can take it home and finish it there.
Is it a test on the last concept or like everything?
Everything. It's not the, it's the last, it just looks like a normal test. Just 20 questions.
Okay.
But Saxon tests are kind of like on everything anyway.
Yeah.
They like test you not on just the last few concepts, but everything, the whole year. That's why Saxon tests get more difficult the farther into the year you get, right? Okay, and then that last day is a Tuesday. So that is like a makeup day if you need it, but we'll probably just be hanging out and enjoying some nice weather.
Do you know if we're gonna do a bring your pet to school day at the last day of school?
Bring your pet to school?
Yeah.
I didn't know that was a thing.
You did it?
Wait, what?
What? We should.
What if you have a pet alligator?
Then bring that.
And why are you?
What if you have a pet?
Guess one time it escaped their
Well,
cage.
you're supposed to bring me goat.
I would pet
Do you
the
have a goat?
alligator.
That's amazing.
Yeah, that was me who sent the group chat.
My mom is probably so jealous.
Okay.
That to me every day I get out of bed. She got like a fall off my bed.
So we're gonna do one more lesson today, and then we'll call it good. And then we'll have the rest of the day to work on homework if you want. If you haven't used your free day, you can use your free day.
We should play Hangman.
I don't like that game. It's very morbid.
We should play add-on.
Okay,
We should
so
play
here's the
anything
deal.
but do problem.
Let's do this. 3x plus 2 equals 17. How do you solve this equation? What do you do first?
You figure
You
out.
could just try to think about it and figure out what it could be. Or you could try to get x by itself. So what looks easier to get rid of, the 3 or the 2?
Three.
How do you get rid of plus 2?
You were raised.
Minus 2, right? So that goes bye-bye. Whatever you do to the left side, do to the right. If you get 2.2 pounds off of this side, you have to do 2 pounds off of this side, so it's balanced. So you get 3x equals 15. You could probably figure it out right now, but what do you do next? How do you get rid of the 3 that's being multiplied by x?
You do 15 divided by 3 equals x.
So you do both sides divide by 3. So x equals 5, right? Okay, so we do the same thing with fractions and stuff like that too. So here's another example. 4/5 x equals 7. How do you get that x by itself? Grace?
So 4/5 times x divided by 4/5,
Okay,
And then
yep. So
7.
divided by 4/5, whatever you do the left side,
then 7 divided by 4/5.
do the right. So now this is a division problem. So how do you write that division problem out?
7 divided by 4/5.
Okay, so copy dot flop 7 times 5/4. You guys okay with that?
Yeah.
So copy dot flop that becomes a 5/4. All right, so then you can't cross cancel. So your final answer is 35/4 or 9 3/4. Okay, or 8 3/4. Sorry. Right? You can leave it like that. That's good. Okay. So let's try another one. See if you can do this. Sorry, like marker. Okay, let's try this one. 2.5 y equals 1 7/8. What did he just do? What makes Evie look like that right now? Why does she look so disturbed? What does she not like about that problem?
No one likes mixed numbers.
No one likes mixed numbers. They should just die.
Oh gosh.
Or we convert them. How do you convert the mixed numbers? What do? Let's change them to improper fractions. So what's a better way to say 2.5?
Wait, I have to think.
5/2.
5 halves. All right, so 5 halves y equals 15/8. Now you could go along and do this. You could divide by 2.5, divide by 2.5. Then you'll have 1 7/8 divided by 2.5. And then you're going to have to change those to improper, right? Because you can't divide mixed numbers. So either way, you're going to have to change them to mixed numbers. So you can do that right away, right when you see them, after you throw up in your mouth a little bit because you hate mixed numbers. You can change it right there, or you can just do the algebra first, and then when you get to a place where, okay, now I have to change them to mixed numbers, do that, or improper, do that. Doesn't matter. But right now, let's just do it. So 5 halves, divide by 5 halves, right? Because 5 halves is being multiplied by y. So this is just 15/8 dot flop. Okay, ooh, that looks pretty.
30/40.
I already used my red marker. Now I have to use a different color. So 30/40, which is 3/4, or you could cross reduce 1 and 3, 1 and 4 to get 3/4 right there. That's not bad, right? Okay, fractions, no matter how good you are at fractions or how bad you are at fractions just complicate things. So it's no longer a nice, cute little problem like that. Now it's fractionated. Let's try yeah. Let's just skip to example 3 and then we'll do example 4 and then we'll call it a day. Here's example 3. You can write this down if you want. Negative 2/3 x equals 4/5. I don't know why it went down to this. Oh, I guess it's negative. So negatives could make it more complicated too, but see if you can do that one.
Is it negative 2/3 or negative 2/3?
Yes,
Okay.
because that's the same thing. So negative 2/3, so a negative divided by a positive is a negative. So that's negative 2/3, or you could say it's negative 2/3, or you could say it's 2 -3.
What?
Okay.
Well, now you just gave me options and now you work my brain.
All right, what do you got?
Can you say the problem again?
Yeah. Negative 2/3 times x equals 4/5. I feel your pain, Hunter. I can't see too good all the time.
My mom, if she was like back in the old times, like super back there, she'd be considered blind.
The what?
She'd be considered blind.
Really?
Yeah, she's that bad at eyesight.
Oh.
So sad.
Really, really funny.
Can you
Does she
consider
drive?
someone blind if they're not blind?
Does she drive?
Well, she has contacts and stuff,
Oh, okay.
but yeah,
Look,
yes, she does drive.
remind me not to like be around her when she drives. Hunter, do you have an answer?
Negative 5/6.
All right, let's see if he's right. What do you do? What do you do? What do I do?
You have to divide by negative 2/3.
Yes. So don't forget that negative. That's very important. So dividing by 2/3
Oh, wait, I did this backwards.
is the same thing as multiplying by negative 3
I
halves.
did it backwards.
Okay, right? Does anything cancel?
Oh, wait, yeah. The
Yeah.
4 and the 2.
4 and the 2. I mean, you don't have to cancel, but it's so much easier if you do. So 2 times negative 3 is negative 6. 5 times 1 is 5. There's your answer. If you didn't cancel, you would have gotten negative 12/10, which reduces to negative 6/5. So positive divided by a negative, remember that's a negative.
I did it all correct, except I
Did you
didn't
forget
get
to flop
X
it?
by itself.
Oh, what'd you do? So what did you get? You got
the
5.
first one divided by the second.
Yeah, so you flopped the wrong thing.
Yes.
Yep, so that's a very common mistake. Don't flop anything until you have a division problem. This is not a division problem, right? So you're not going to flop anything here. Now you have a division problem, so you can flop what you're dividing. Don't flop what you're dividing from, flop what you're dividing. Okay? Don't flop the wrong thing. That's embarrassing for everybody. Oh. Okay? One more?
No.
Call it good? You want to do 2 more?
No, one's
Oh.
good. One's
There you
good.
are.
One's fine.
You said no, so I figured you wanted to do more.
No.
Okay, ready? Negative 5x equals 0.24. What? No matter how good you are at decimals just complicate things. So you can just use the same rules with the easy problems. No problem. Yeah,
I didn't get the full thing. Can you say it again?
yep. Negative 5x
I know how to do
equals,
it, I just really don't want to pull out paper.
equals 0.24.
Nope.
Yeah.
Sometimes I find my brother's voice soothing to my ears.
Okay.
Sometimes I don't. What? Did I quote a song?
Yeah.
Okay. Yay. What song? Okay, so what needs to be done here?
Oh, that's not to be so complicated.
What needs to be done, Hunter?
Get x by itself.
Okay, how do you get rid of that negative 5? Adeline?
You divide it by negative 5.
Divide it by negative 5. Now, that part's easy. That's done. You never have to worry about it ever again in your whole life. Okay? But 0.24 divided by negative 5, well, we know how to do that. Well, first of all, positive divided by negative is a negative. So let's forget about the positive and negatives and know that our answer is just going to be negative. So now we're just going to divide 5 into 0.24. How many times does 5 go into 2?
Yeah.
How many times does it go into 24? 4. Now we can add as many zeros as we want.
8.
Goes in 8. So look at that. So x equals 0.048 or 48.
Wouldn't it be? Did you put negative? 'Cause-
Oh, I didn't. See, that's the same thing I did on the test too.
Yeah.
We already said it was going to be negative, but
Wait,
then
do I get a? Does that count as a mistake?
I already gave you already corrected me on that same mistake.
Still, I corrected you again. Wait, did anybody else notice that on the test?
Kiara noticed that as well.
What?
So we already established that those answers were positive or negative. And so if you don't put that in your answer though, you're gonna forget to put that. So if you just decide if it's gonna be positive or negative, then that makes it a little less confusing. Then you don't have to, it's not dividing by negative 5. Okay, is that positive? You know, just decide that already. Put that in your answer. Go back and do the math and put the rest of the answer right next to that negative sign, okay? If you don't do that, you're gonna forget it like I just did. Okay? That's it.